Metals are elements that lose electrons easily, that are lustrous, reflective, malleable, can be molded into other shapes, and are good conductors of heat and electricity. Metals are crucial to our ways of life. Not only are they part of our structures and technology, but they are important to the manufacturing of nearly all items. A quick survey of our surroundings yields a variety of metals with important roles. What we don't always notice, though, is that our bodies are also dependent on metals. Glancing at the nutrition label of a multivitamin, you'll see dozens of metals listed. Maybe you didn't know that sodium, calcium, magnesium, and zinc are all metals. These metals are necessary for life, and if they're missing in our bodies, our health can be severely compromised. For example, calcium is necessary for healthy bones, and magnesium for metabolism. Zinc boosts immune system function, and iron helps our blood cells carry oxygen around the body. However, the metals in our bodies are different from the metal in a spoon or a steel bridge in that they have lost electrons. They are called cations. More on this later. Metals also have antibiotic properties, which is why railings and handles in public areas are often made of metal. Some orthotics are even made with silver to prevent bacterial growth. Artificial joints are made from titanium alloys that simultaneously prevent infection and make the recipients stronger. The majority of elements on the periodic table are metals. This periodic table groups elements according to type: metal, blue, nonmetal, yellow, or metalloid, red. All of the metals are grouped together on the left side of the periodic table. Notice that hydrogen is grouped with the metals in the top left corner. Even though it is grouped with the metals, hydrogen is considered to be a nonmetal. Some scientists theorize, however, that there could be metallic hydrogen in the core of the planet Jupiter. Many of a metal's remarkable and useful qualities stem from the way that metal atoms bond with each other, known as metallic bonding. Metallic bonding is how metal atoms interact at the atomic level. It is how metal atoms connect to make larger metal structures. Any sample of metal you see, from the metal in your car to the coins in your pocket, is engaging in metallic bonding. In metallic bonding, metal atoms share their outermost electrons evenly with each other in what is often referred to as a sea of electrons. Electrons flowing between the positively charged metal ions transmit heat and electricity with ease, making metals such good conductors of heat and electricity. Copper wires are used to conduct electricity. Reactivity refers to the tendency of a metal to react with chemicals in its surroundings. The reactivity of metals varies greatly. Some metals, such as those in columns 1 and 2 on the periodic table, potassium and sodium are examples, react easily with many different chemicals and are rarely found in their pure elemental form. Both of these metals are usually only found in compounds, bonded to one or more other elements, or as ions, a charged version of their elemental form. On the other hand, there are other metals, like the jewelry metals of gold, silver, and platinum, which are not very reactive at all and are commonly found in their pure form. These metals lose electrons more readily than nonmetals, but not as easily as reactive metals like sodium. Platinum is relatively unreactive and is very resistant to reactions with oxygen. It can be in the same environment as oxygen without reacting for hundreds of years. When metals do react, they lose electrons to become positively charged ions, or cations. Some metals always lose the same number of electrons, while others can lose different numbers of electrons. The metals in column 1 always lose one electron to form a +1 cation. The metals in column 2 always lose 2 electrons to form +2 cations. Remember when we said that the metals in our bodies are cations? If you look at these two columns, you'll see several of those elements: sodium, magnesium, calcium, and potassium. The metals in columns 3 through 12 are more flexible with the types of cations they can form. For example, iron, also in our bodies, comfortably forms ions of +2 and +3, and manganese can be a +2, +3, +4, or a +7 cation. It's very common for metals to react with nonmetals to form ionic compounds. An ionic compound is a neutrally charged compound that is made from the mutual attraction between a positively charged metal cation and a negatively charged nonmetal. When pure metals and pure nonmetals react, the nonmetals typically steal electrons from the metals in what is known as an oxidation reduction or redox reaction. Rust is an example of a redox reaction. When oxygen from the atmosphere steals electrons from iron metal, rust or iron oxide forms. Metals are elements that lose electrons easily, are lustrous, malleable, and are good conductors of heat and electricity. Metals generally have high melting points and are solid at room temperature. Metals bond by sharing electrons in what is known as metallic bonding. Metals are important to humans in a variety of ways. Metals can be used to make tools, build structures, and conduct electricity and heat. Metal ions play different vital roles in the body, and metals have antibiotic properties. Metallic bonding happens when metal atoms share electrons with each other in a sea of electrons. When metals react, they lose electrons to become positively charged ions, or cations. Some metals are extremely reactive and rarely exist in their pure form, like sodium and potassium, while metals like gold and silver are not very reactive and are commonly found in their pure form. Metals commonly react with nonmetals to form ionic compounds. An example of this is rust, oxygen from the atmosphere stealing electrons from iron.